Hey guys, welcome to the level 2 algebra paper from 2019. In this video, what I'm going to be doing is going through all of the questions. So the way this video works is that what I would recommend you guys to do is pause the video at the start of each question, try and do the question by yourself, and then just watch the video just to see how I do these questions. Some questions, they do have different ways of doing it, so there's actually more than one or two ways to do them. So I try and work out the way that I think it's easy, but of course it might not be for you, but that's another story. And of course, remember that graphics calculators are allowed in this exam, so learn how to use that as well. It's just a nice way to kind of move things really fast for you. Okay, enough chat. Let's go to question number 1. All right, so question number 1 is what we have is a quadratic that we need to solve for. So the first step is actually rearranging this quadratic. So I'm going to rearrange this to be 3x squared, bringing the 7x to the left-hand side. It becomes minus 7x. And of course, I've still got minus 6 here, and all of this is equal to 0. Now, at this point, in level 1 maths, you had to actually factorize this, put it equal to 0, and solve it, right? Well, just remember that you do have the graphics calculator that you could use. And so I would actually say use the graphics calculator to find the answers, and then you can rewrite the factors back. It's a bit of a little short hack. It does work, and I think I've actually shown how to do this in one of my videos, so check it out in the level 2 algebra videos just to show you how to work backwards. So what I'm going to go is go into menu and go into equation, and in there I want to be selecting polynomial, which is F2. Degree is 2, and at this point what I need to do is look at my a value, which is the value in front of x squared. In this case it's 3, and I've got negative 7, which is in front of x, and I've got negative 6 in front, the number by itself. So when I do this, I end up with two answers here, and the two answers are that x is equal to 3 and x equals to negative 2 over 3. Now notice how the answer is coming in decimal point here, but then it does show it here as a fraction. Okay, so what you could do is then just write the two answers down. So you could actually write down that x is equal to 3 or negative 2/3. Now, here comes the hack. So what I mean by the hack is this. To actually factorize this from the solutions, remember that if x equals to 3, then rearrange it so that the right-hand side is actually equal to 0. So in other words, this is going to look like this: x minus 3 equals to 0. And then the same thing with x equals negative 2 over 3. But the only thing is, when you have a fraction, you got to cross multiply first. So in other words, you got to rewrite this as 3x is equal to negative 2, and then write in 3x plus 2 equals to 0. So now what happens is, this is one of your factors, and this is your second factor. And the hack is just putting this just before your solutions like this: 3x plus 2 multiplied by x minus 3 equals to 0. Now, in all honesty, guys, I don't know, and I have to read the clarifications. If you just put answers only, will you get it right? I always say play it on the safe side, so have the factorized version of that quadratic in there. Okay, so grades wise, this ends up being an achieved question. All right, let's go to question 2, or part 2 of this question. So with this question, it again is a quadratic, but of course we've got to actually manipulate this quadratic first. So the easiest way to do it is let me just write down all of this here, just into a little bit bigger space. So the first thing I want to get rid of is the x squared under the 3. So what I'm going to do is I'm going to multiply everything by x squared. So I'm going to multiply the 5 by x squared. I'm going to multiply 4 by x squared in the numerator, and the 3 also multiplying by x squared. So when I do this, what happens is the x squareds start disappearing. So because x squared is in the denominator and the numerator, it disappears. So what I'm left over with is just 3. Plus, I've got x squared in the numerator, so this gets written as an x in the denominator. So I'm cancelling out just one of them. So it's going to be ending up looking like this, as 4x. And then finally, this is all equal to 5 times x squared, which is 5x squared. Okay, so all I've done is I've just multiplied each of those elements by x squared. So now I've got a nice quadratic, and I'm going to rearrange this so that 0 is equal to 5x squared minus 4x minus 3, and now I need to just solve this. So I'm going to put this in the graphics calculator, or you can use the quadratic formula as well to try and work out what your two solutions are. So going into the equation again, and I've got my a value, which is equal to 5. My b value is -4 because that's the number in front of x, and my c value is -3. So putting it all in, as you guys can see, I've got two answers here. Now these answers are not a fraction. As you can see, they are recurring decimals, so it just keeps going. So therefore, very good chance that we can't actually factorize it. So, well, probably can. I'm not going to mess around with this right now, guys. I just want to get through this paper. So those are our two solutions right now. So then x is equal to 1.27 and -0.47. Now this question is, yet again, it is an achieved question. And so we leave it at that. Okay, moving to question 1b. All right, so what we have is, we've got a quadratic equation, yada, yada, yada. And we have drug is used for daily dose. So K is the initial cholesterol level. So I'm just going to kind of highlight that part there. And the function is valid for the first 15 months only. Okay, so that's something important right here, that it's only valid for 15 months. And it also says that there's an initial stuff is getting repeated again, initial cholesterol level of 9.18. And so what we can kind of see is, and we are asked to find out how long will it take for the person's cholesterol level to blah, blah, blah. Okay, fine. So what we really have is cholesterol level is equal to 5.05. And we want to know when it's 5.05, what is t equal to? We also know what the initial value is, because that's 9.18 as it's highlighted in the yellow parts there. So we're going to rewrite this equation now, and what we're going to end up with is 5.05 equals 0.02 t squared minus 0.6 t and plus k. Now k is equal to 9.18, so I'm going to leave that as 9.18. So rearranging this equation, I'm going to get 0 is equal to 0.2 t squared minus 0.6 t plus 9.18. And of course, when we bring 5.05 to the other side, it is negative 5.05. So simplifying this, we're going to get 0. 0 is equal to 0.02 t squared minus 0.6 t plus 4.13. So as you guys can see, we have another quadratic equation. So again, we're going to use the graphics calculator to try and solve this. So what we have is our a value is the value in front of t squared, which is 0.02. So we have 0.02, and then we've got negative 0.6, and then we've got 4.13. So when we actually solve this, we actually end up with two answers for t. We've got 19.3 and 10.7. So I'm going to put that down here first. So t is equal to 10.7, and we also have 19.3. But I think the important thing to understand is that t was months. So we got 10.7 months and 19.3 months. But if you go back to that highlighted part that's in green color, the function is valid for the first 15 months only. That means t cannot equal to 19.3. So you have to actually say that t is equal to 10.7 as 19.3 is bigger than 15 or something like that, to say that you only have one answer. Cool. So grades wise, putting the equation equal to 0 gets you an achieved. Wow. So getting up to here gets you an achieved, and of course getting the right answer gets you a merit for this particular question. Cool. Moving on to the next one. All right, question C here. It's just wordplay, this question. I mean, I remember talking to some of my students at the end of last year. They said that they didn't actually understand this, but in reality was that, you know, you guys actually do know if you've been attending my live tutorials or if you've been kind of just understanding what that word perfect square means. Now, what is the meaning of perfect square? Let me just give you guys a little example and it'll start making sense, right? Perfect square is when you have something like this. You know how you have like x plus 3 squared? Well, that's a perfect square. So basically the perfect square is just like, you know, if we take 5 squared, that's 25, so 25 is a perfect square. So in this case, if we're dealing with a polynomial with x squared, so all it means is that it is, it's one of these things like x plus 3 squared, or maybe something like, you know, it could even look ugly like this, 2x minus 3 squared, stuff like that. But what you need to understand about perfect squares is that they only intersect the x-axis once. Because if you think about it, perfect squares, remember, they look like this. You know, if it's x plus 3 squared, it's going to look at that point as minus 3. So it only touches the x-axis once. That's what a perfect square actually does. So in other words, it cuts the x-axis once, which means the discriminant has to equal to 0. So that is all that means when we say that it is actually, it can be written as a perfect square. So we're going to then say the first step is that discriminant is equal to 0. So in other words, we're going to put down b squared minus 4ac equals to 0. So once we do this, next part is actually working out what your a, b, and c are. So we've got a, which is 2m minus 1. We've got b, which is m plus 1. And then we've got c, which is m minus 4. So that's your a, b, and c. So now it's just a matter of substituting all of them. So b is m plus 1. So that's going to be m plus 1 squared minus 4 times a, which is 2m minus 1, times c, which is m minus 4. And now all of this is actually equal to 0. So just recapping that, guys. So b is m plus 1. Oh, wrong color. So b is m plus 1, which is the green part highlighted there. The a is the blue part, which is there. And of course, the c is m minus 4. So now what we have is a quadratic equation that we just need to expand and simplify and put it equal to 0. So we've got m plus 1 times m plus 1. M plus 1 minus 4. And I'm going to do that, expand this quadratic here. So 2m times m is 2m squared minus 8m minus m plus 4. And all of this is equal to 0. Now m plus 1 squared just becomes m squared plus 2m plus 1. And I've got minus 8m squared plus 32m plus 4m, I should have simplified that, minus 16 equals to 0. So simplifying this, now we've got negative 7m squared. I've got 32, 4, and 2, which ends up being plus. Let's try that again. Plus 38m. And we've got negative 16 plus 1, which is negative 15, equals to 0. So at this point, we're actually going to solve this using the quadratic equation, guys. And what we've got. So go back into the quadratic formula. So our a value in this case is negative 7 because that's the coefficient of m squared. Then we've got 38, coefficient of m, and we've got minus 15 by itself. So when we solve this, we're actually getting two answers here. Our first answer is 5. And our second answer, which is a fraction, which is equal to 3 over 7. So we're going to put down m is equal to. So we're going to put down m is equal to 5 or 3 over 7. However, this part is important. It's especially at level 2 algebra papers. It's always a good idea to go back and check if the final answer, the two answers that you get, are correct or wrong. Okay. So the way we're going to do it is that we're going to go back to this whole concept of perfect square. So if the polynomial is a perfect square, then what we're going to be looking at is just the c value here. All right, the c value has to be a square number, otherwise this entire polynomial will not be a square number. What do I mean by that? So have a look at this x plus 3 squared. Now if I expand it, I'm going to get x squared plus 6x plus 9. And notice that 9 is actually a perfect square. So I'm just going to take that m minus 4 and I'm going to substitute 5 and 3 over 7 and to see which one is going to give me a perfect square number. So if I take m equals to 5, so if I put m equals to 5, then m minus 4, I'm going to get 5 minus 4, which is equal to 1. Now this is a perfect square, so this is fine because 1 is a perfect square. That's going to work. But if I put down m is equal to 3 over 7, then I'm going to get m minus 4, which is 3 over 7 minus 4, which equals to negative 25 over 7. Now this is not a perfect square number, so this one is not actually going to work out. So we need to kind of state then, therefore m is equal to 5, as m minus 4 must be a perfect square. Just give myself a little bit more room. So guys, what we have then is, I believe we've finally cracked this question here. So grades wise, what we're looking at is set sub discriminant equal to 0. It is an achieved. So I'd probably say that is a tricky one, this one, because I'm almost wondering, like, are they actually talking about, I'm not sure which part they're actually mentioning for achieved, whether it's actually saying that b squared minus 4ac equals to 0. I think they're saying set sub discriminant equal to 0, and so if that's the case, I'd probably say you need to get up to there. Set sub quadratic equation equal to 0 is a merit, which is this line here. And then excellence is kind of rejecting that 3 over 7 and coming up with just m is equal to 5. So that part is important. Yeah, so that's how you basically do this question, guys. All right, so let's go to the next question. Okay, so question D here. What we asked to find is find an expression in terms of p for the difference between the roots of this equation. So we've got to actually first find the roots of the two equations. Once we find the roots of the two equations, then we can actually subtract it. Now looking at this, the biggest clue that you could get here is that the px is actually in a bracket. All right, and what I would do is I would highlight just the px, and I'll find that this is also highlight the other px in this quadratic. So what I'm going to do is I'm going to get rid of that px, and I'm going to rewrite this as something like, maybe I'm just thinking of a word that I could use, m. Let's go with m. So if I put m is equal to px, then I can rewrite this entire equation as m squared plus 4m minus 12 equals to 0. Because I've said that m equals to px, and I've just replaced px with m, as you can see in that highlighted part. Now I've got a really nice simple quadratic which I can factorize, because I know that this is going to be m plus 6 and m minus 2. So I can then solve these two things, because I've got m plus 6 equals to 0, or m minus 2 equals to 0. So in the first case I get m equals negative 6, and in the second case I get m equals positive 2. Now I also said that, so that's what px then is equal to, right? Because I've just figured out what m is. M is minus 6 or 2. That means we can say that px equals negative 6, or px equals to 2. Now it says find an expression in terms of p for the difference between the roots. So I'm going to rewrite this as just x by itself, because that's what the root is. So I'm going to get x is equal to negative 6 over p. And in the other situation, I'm going to get x is equal to 2 over p. So these are my two roots, or two solutions for this particular quadratic. And now I need to figure out what the difference between the two is. So I just take the first root. Now in this case, I don't negative. Let me just have a look. So I'm going to take the big one and minus it from the small one. So 2 over p minus negative 6 over p. So when I subtract this, I'm going to get 2 plus 6 over p, which means I'm going to get 8 over p as the difference. Sorry about that, guys. So 8 over p is the difference. All right, so in terms of grades for this question, really funny that I've not seen a question with 3 excellence questions before, but this is classified as an excellence. So for achieved, factorizes correctly or finds the difference between roots consistently. So we are looking at achieved is probably here, where you're factorizing it. And then if you make a mistake with the roots, but you still know, kind of do the right thing, but with the wrong answers, you can still get an achieved. Merit is correct roots are found. So this is probably at a merit level. And then the difference between the two roots is excellence. All right, so let's go to question 1E. Question E here is a funny one because there's actually 2 ways to do this. One is you can actually just argue about this particular question through graphs, which in theory is algebra. So you could kind of do a graphical argument, as they've actually mentioned in the exam schedule. But well, let's actually have a look at this. All right. So the first way I'm going to do is I'm going to try and prove that the discriminant is actually bigger than 0, and if it's bigger than 0, then it's going to have 2 roots. So I'm going to expand this quadratic that I have right now. So I've got y is equal to x minus a, x minus b, minus c squared. So when I expand this, I'm going to get x squared minus xb minus ax plus ab minus c squared. So I'm going to now factorize the terms inside, which is, I'm talking about the coefficient of x. So I can rewrite that as minus a plus bx plus ab minus c squared. And the reason I did this was because if you look at this, negative times a times x is negative ax. And then if I do, need a different color, there we go. And if I do negative b times x is equal to negative xb. All right, so that's all I've done there. Now I just need to prove that the discriminant is equal to, greater than 0. So my a value is in front of x squared. My b value is this entire thing here. And my c value is this thing right here. So I'm going to write down my discriminant, which is b squared minus 4ac. So I've got negative a plus b, and that's whole squared, minus 4 times 1 times c, which happens to be ab minus c squared. So this is what I have. So the next thing is I've kind of got to expand this out. So I'm going to get a plus b. The negative squared becomes positive, so I can just rewrite this as a plus b squared minus 4ab plus 4c squared. The next thing is I need to expand the quadratic of a plus b times a plus b. And then I still have the minus 4ab plus 4c squared. I'm going to get a squared plus 2ab plus b squared minus 4ab plus 4c squared. Kind of carrying on here, but the 2ab minus 4ab is equal to negative 2ab. So I'm going to get a squared minus 2ab plus b squared plus 4c squared. Now what I could do is I could actually factorize this. And when I factorize this, I'm going to get a minus b squared plus 4c squared. So at this point, I've got to prove that the discriminant is a number that's actually bigger than 0. And the way I'm going to show that is this right here. See, this is a perfect square, because it's a number and it's squared. And then you've got c squared. C, if it's a number and it's square, it's going to be a perfect square. Times it by 4. 4 is also a perfect square. So you've actually got perfect square plus a couple of perfect squares. And the biggest thing to notice is that back in the question, it actually says that c is not equal to 0. So that means no matter what number c is, you're going to end up with a perfect square, which is going to be a positive number. And because that's a positive number, we can actually say that the discriminant is equal to 0. So the way we say it is like this. A minus b squared is actually greater than or equal to 0. And we can also say that 4c squared is greater than or equal to 0. Therefore, the discriminant is greater than 0, not greater than or equal to. Sorry, I should have put that as greater than. Discriminant is greater than 0, which means this polynomial which means 2 roots exist. So this is the algebraic way of doing this question. Now, if you're trying to figure out what is the graphical way of doing this question, is you could do it like this. The first thing is that because c is not equal to 0, then c squared has to be bigger than 0. All right. Now, if c squared is actually bigger than 0, in a graph method, it's going to look like this, where your 2 roots are going to be there, where this is a and this is b. Maybe I should have put something like this. And then c squared is going to be here. But remember that this quadratic is actually x minus a times x minus b minus c squared. So minus c squared is actually going to be below the x-axis. And so it actually has 2 roots. I probably have not explained this as much as I would like to in the graphical method, but it's just kind of drawing it up here, but also kind of stating that since c squared is positive, y equals x minus a times x minus b minus c squared. What can I say? Is below, or we can say is cutting x-axis at a and b, and since c squared is positive, the parabola is, I'm trying to think of the word to actually say. So how do I say that? It cuts the x-axis and then it goes below the x-axis and it comes back out. Yeah. I might actually say the parabola is as shown in the diagram above. Yeah, not sure if they'll accept it, but it's just I am not a wordsmith, you know, I struggle with that part of it. But so excellence achieved merit. Function is set up so the discriminant can be found. So function is set up the discriminant, so that's probably there where we're saying that it's achieved. Finds discriminant in factored form. That's going to be here. And then excellence is the final part. Now, if you're choosing to do the graphical way, there's only one answer, and that's, only one grade, and it's just the excellence grade right there. Okay, so that's question 1, folks, and we are going to question 2. All right, question 2, we have a nice index question here. So what we could do is rewrite this as 9 to the power of 0.5, a to the power of 2 times 0.5, and b to the power of minus 4 times 0.5. Now 9 to the power of 0.5 is just 3, because that's just square root of 9. And then we've got a times 2 to the power of 0.5, which is a to the power of 1. And negative 4 times 0.5 is negative 2. Now remember, this question you have to leave with positive indices. So we're going to rewrite this as 3a over b squared. Nice and easy achieved question to start this question 2 with. Okay, so let's go to the next part of this question. So again, writing this in positive indices. So we're going to rewrite this as, and I always say this, if you're working with negative indices, just flip the fraction and change the power. So in this case, you can rewrite this as 3b4 over 2a, and now that's written as to the power of 2. So expanding the brackets, we're going to get 3 to the power of 1 times 2, b to the power of 4 times 2, divided by 2 to the power of 1 times 2, and a to the power of 1 times 2. Now, if you're wondering where that 1 came from, remember that 2 to the power of 1 is just 2, a to the power of 1 is just a, and 3 to the power of 1 is just 3. So that's where the 1 is actually coming from. And a lot of people actually forget about it, and they make silly mistakes with that. But anyway, we've got 3 squared, which is 9, b to the power of 8, 2 squared is 4, and then we've got a squared. So this question also ends up being an achieved. Okay, so let's go to question B. All right, so with this question here, what we've got is we need to write this as a single fraction. And a lot of people, what they end up doing is they do cross multiplication, and they end up with some of the most ugliest equations possible. And then of course you've got to try and write this in a simplest form, which of course creates more havoc. So the best thing to do is to factorize the denominators. So what I mean by that is this. In the first fraction, we're going to write that as 2c plus 1 divided by, and instead of writing it as c squared minus 9, we can write it as c minus 3 and c plus 3. Plus, we have c minus 2. And we're also going to factorize the denominator here. So when I factorize the denominator here, I am going to get c minus 3 and c plus 1. No, c minus 1, sorry. So at this point, I can have a look at my denominator. I already have a c minus 3 in my denominator, so I don't have to actually worry about it. On the left-hand side, I have a c plus 3, so I need to make sure I get a c plus 3 in the denominator on the other side. And on the right-hand side, I've got a c minus 1. I also need to make sure I get a c minus 1 in the denominator on the left-hand side fraction. So in other words, I'm going to rewrite everything as it is. So I'm going to get 2c plus 1. I've got c minus 3, c plus 3, plus c minus 2. And I've got c minus 3 times c minus 1. And of course, the green part that's highlighted is c plus 3, which means I need to do it like this. So I multiplied the denominator by c plus 3 and the numerator by c plus 3. And likewise, on this side, I'm multiplying by c minus 1, and I've also got to multiply the numerator by c minus 1. So now I've got a lovely quadratic on both sides, so I'm going to expand that quadratic out. So I'm looking at this right now. So I've got 2c times c, which is 2c squared, times 1c times 1 is just 1c. Then I've got negative 1 times 2c, which is negative 2c. Negative 1 times plus 1 is negative 1. Plus c minus 2 times c plus 3. Well, that's kind of nice and simple. I can just go c squared plus c minus 6. And the whole thing is now divided by c minus 1 times c minus 3 times c plus 3. Simplifying it, I've got 2c squared. Have I made a mistake somewhere? No, it's looking good so far. 2c squared and c squared is basically looking at those two things. That's 3c squared. The c's, I've got c minus 2c, and then plus c becomes 0. Negative 1 and minus 6 becomes negative 7. And the whole thing is now divided by c minus 1, c minus 3, c plus 3. So I've written it as a single fraction, and it's in its simplest form. So for an achieved cross arrangement to a single fraction, we're probably looking at something here. Final simplification is a merit. All right, so that now takes us to question 2C. So in this question, what we've been asked to do is factorize fully. And what are we going to do here? So the way we're going to do it is maybe we'll look at the first couple of terms and see if we can actually factorize it. And if we can't, then we just have to kind of mess around with this till we get an idea. So what I'm going to do is I'm going to maybe look at just the f, for example. So I'm going to rewrite this as fm plus 3fn minus 6gn minus 2gm. So what I'm trying to do is, all I've done is I've just kind of rewrote those two things, right? And I'm going to split them up into two kind of parts, and I'm going to factorize the first part on the left hand side and then the right hand side. So on the left hand side I can see that f is a common factor, so I can take it out, which means I'm going to end up with m plus 3n. And on the right hand side, ideally I want to end up with m plus 3n, but let's just see what happens. I've got g as a common factor and negative 2. I'm going to take out negative 2g as a common factor. Then I'm going to end up with 3n, and I'm going to get plus m. So as you guys can see, now that those brackets are exactly the same things, but they're just written in a different way. So I'm just going to rewrite them as this, minus 2g and then m plus 3n. Now at this point, both of these two things are common factors, and because they're both common factors, I can rewrite this as f minus 2g multiplied by m plus 3n. So all I've done is I've taken the f and I put it there, minus 2g into there, and the m plus 3n is a common factor. So looking at grades wise, pairs factored, you're probably looking at an achieved somewhere here, and then full factorization gets you a merit. Alright, so let's go to question D. Remember this question. This question caused quite a bit of controversy last year, and I think even as I'm making this video, there was just an article that popped up on Herald about this question. So they actually gave the incorrect diagram, if I'm correct, in the original exam, but obviously they've actually changed their diagram, hopefully. But yeah, so let's actually try and work out this particular question here. So the first thing to understand is that the shaded rectangle has an area of 9 centimeters squared. All right, so if we look at it, we basically have this right here. So we've actually got the height and the base of this rectangle, because the height of this rectangle is equal to y, because notice how that length of y is the same as the length of the height of that rectangle, and the base of that rectangle is going to be y minus 8. So what we actually have is the first equation, which is base times height, which equals to 9. Now the base is equal to y minus 8, and the height is equal to y, and this is equal to 9. So we can rewrite this as y squared minus 8y is equal to 9. And what we can actually do is factorize this and figure out what y is. So when we rearrange this, we're going to get y squared minus 8y minus 9 is equal to 0. Let me just get rid of this little thing here. Just need some space. Although mind you, that part comes later on, that whole idea behind the diagram not to scale. Anyway, we're going to factorize this, and so we're going to get y minus 9 multiplied by y plus 1 is equal to 0. Therefore, y is equal to positive 9 or negative 1. We need to use y is equal to 9. Y equals 9 as distance can't be, length can't be negative 1. Length can't be negative 1 centimeters. Okay, so we've actually figured out that first part. The next part, what we need to do is to try and figure out what x is equal to. Now the reason why we need to figure out what x is equal to, because we want to try and figure out what the area of rectangle ABCD is. And the rectangle ABCD, the base is actually here, and the height is there. So what we then have is, so we want to try and figure out what x is. And the way we're going to figure that out is, we know that x is equal to, let me just put it here, y minus 8 and y plus 2. So I'm actually going to do that first. So we can kind of say that x is equal to y minus 8 plus y plus 2. So we're going to get x is equal to 2y minus 6. So this is the base right now. So when x is equal to 2y minus 6, I'm saying that this part right here is 2y minus 6. Now we need to find that height of this orange rectangle. And the height of that orange rectangle is actually equal to x minus 4. All right. So if we say, so we've got x in terms, so hang on, let me just go back and put this. So this is for the base right now. Now we're going to work out what the height is. Now the height is actually x minus 4. And because the height is x minus 4, we can replace x with 2y minus 6, because that's what we said x was in terms of y. So I'm going to rewrite that as 2y minus 6 minus 4, which then simplifies to 2y minus 10. So that 2y minus 10, so instead of writing x minus 4, I can write that as 2y minus 10, which happens to be the same length from there to there. So now I have the equation for my area for the rectangle. So area for the rectangle now, let me just get some more space here. So area of rectangle is going to be, let's just put rectangle ABCD. We have base times height. Now the base is equal to 2y minus 6 multiplied by height, which happens to be 2y minus 10. Now we know that y is equal to 9, so I'm going to substitute 9 in there. So I'm going to get 2 times 9 minus 6 multiplied by 2 times 9 minus 10. And when I do this, I get 18 minus 6, which is 12, 18 minus 10, which is 8, and I've got 12 times 8, which equals to 96 centimeters squared. All right, so this is what we're looking at for this particular question. It's a weird question because it only has achieved or excellence. It doesn't really have a merit. So if you figure out what y is, you get an achieved. And if you find out what the area is, you actually get an excellence. Strange question. But as I can imagine, the original question caused a bit of controversy. But yeah, so anyway, we'll move on to the next question. All right, question 2e, what we need to do is we need to it's a proof question. We need to actually figure out what the root of those questions are. So what we're going to do, sorry, not the question, the polynomial. So we got x squared plus bx plus q equals to 0, right? We are going to find what the roots are first. So the only way to do this is a equals 1, b equals to p, c equals to q. And we're going to use the quadratic formula for this. So we're going to get x equals minus b plus or minus b squared minus 4ac over 2a. So we've got x is equal to minus p plus or minus p squared minus 4 times 1 times c. So that's going to be p squared minus 4q divided by 2. So our two roots at the moment, our first root is going to be negative p plus square root of p squared minus 4q over 2. And our second root is going to be minus p minus square root of p squared minus 4q over 2. So these are the two roots. Now if we go back to the question, it says one root is n times the other. So I'm going to take my first root, and I don't think it matters which way you go about it, but I'll use the plus one here and go p squared minus 4q over 2 is equal to 4 times, not 4 times, what am I doing? N times the other. So n multiplied by minus p minus square root of p squared minus 4q over 2. Now the first thing to understand is that because both of these fractions are being divided by 2, we can actually forget about the 2 and just rewrite this as minus p plus square root of p squared minus 4q equals n multiplied by minus p minus square root of p squared minus 4q. Now what I need to do is I need to expand the brackets on the right hand side. So I'm going to get minus p square root of p squared minus 4q equals n times negative p is negative np minus n square root of p squared minus 4q. So all I've done there is just n times negative p and then n times whatever's next to that square root symbol. So at this point I need to rearrange things so that I can factorize. So I'm going to bring in the negative n. So basically I'm going to bring in this to the left hand side, and when I do that I end up with n square root of p squared minus 4q plus square root of p squared minus 4q is staying as it is. And in this side I've still got negative np, but I would like to bring the negative p to the right hand side so it becomes positive p. Alright guys, at this point in the left hand side what you have is square root of p squared minus 4q is a common factor. So we can actually take that out, and what we're going to be left with is brackets n plus 1. So if you want to figure out where that n plus 1 came from, the n came from there and the 1 is from there, which equals p is a common factor, so I can take it out and I'm going to get 1 minus n. Now the next step is actually rearranging this so that I've got to figure out a way to get rid of the square root symbol. So I'm going to rewrite this as p squared minus 4q equals p times 1 minus n divided by n plus 1. So this is what I've got up to, and somehow from this I need to actually get up to here. So the only way I can do that is by actually getting rid of the square root symbol. And if I want to get rid of that square root symbol, I have to square both sides. So p squared minus 4q, and I'm going to square it. And then I've got p times 1 minus n, n plus 1, and I have to square this as well. And so when I do this, I'm going to get p squared, the square root symbol disappears, and I've got p squared minus 4q. And then in the numerator here, I'm going to get p squared multiplied by 1 minus n squared divided by n plus 1 squared. Now, this is going to be an ugly looking quadratic, like ugly looking algebraic expression, but somehow we need to actually get it to that stage that's actually highlighted in green there. Okay, now it's going to take a bit of a process, but it'll work out, hopefully. So we've got p squared minus 4q equals p squared, and multiplied by 1 minus n squared is 1 minus 2n plus n squared divided by n squared plus 2n plus 1. Now I got to cross multiply this, so I'm going to end up with n squared. I'm sure there's got to be an easier way to do it than this, but I'm not sure how. So p squared minus 4q equals p squared times 1 minus 2n plus n squared. So what we have is an ugly looking quadratic that we've got to expand out. So we've got n squared times p squared is equal to n squared p squared minus 4qn squared. Then we've got plus 2n p squared, and then we've got minus 8nq plus p squared minus 4q, and all of this is equal to p squared times 1 is p squared minus 2n p squared plus n squared p squared. This really is a horrible question. That's all I can say. All right, let's see what we can actually get rid of. So the first thing I want to get rid of is the p squared and p squared. N squared, p squared. Okay, n squared, p squared disappears. All right, I'm going to move everything to the other side from the left-hand side. So I'm going to get 0 is equal to 4qn squared minus 2np squared plus 8nq plus 4q, and then whatever's left over on the right hand side, which is minus 2np squared. We're starting to get somewhere, folks. So then I can rewrite this as 4qn squared minus 4np squared plus 8nq plus 4q. Now I can see that 4 is a common factor for all of them, so I can divide everything by 4, and I'm going to get qn squared minus np squared plus 2nq plus q. And then 0 is equal to qn squared. N is a common factor, so I can take it out. So it'll become plus n, and in brackets I'm going to get minus p squared plus 2q plus q. Wow, that is a super ugly question, but I think I did manage to get it in the end. And if you can see the highlighted part there, let's just make it right. 0 is equal to qn squared plus n 2q minus p squared plus q. Yeah, ridiculously long question for level 2 excellence. That's all I would have to say. Successfully squares both sides gets you a merit. So I think your merit is almost up to here. Achieved is 1 root times the other, which is here. Wow. And then excellence is here. I'd have to say this is a challenging question at this level. Just I'm looking at the amount of time that I actually spent on it. I think I spent nearly good 10 minutes on this question explaining to you guys, and this kind of, you get 60 minutes for this paper, and to do a question like this is just mean. That's all I can say. All right, anyway, let's go to the next part of this question. So we're going to question 3. All right, guys, with question 3a, the first step that we want to be doing is we want to rearrange this. So log 5m is equal to 3, and then using our log rules, we can say that m is equal to 5 to the power of 3, and m is equal to 125. Nice question for an achieved. Yeah, I look at this question. It took me like not even 30 seconds to do this, and then the previous question that takes me 10 minutes to do. God, frustrating sometimes with these questions. All right, next part of the question B, we're looking at writing it as a single log. So we're going to write this as log of 6 minus log of y squared. Because remember, that's actually one of the log rules. When you have a number in front of log, you can actually bring it as a power. And then because we're subtracting, we can now rewrite this as log of 6 divided by y squared. Another nice and straightforward achieved question. All right, let's go to the question C. Whoa. Now, looking at this question, guys, it is very easy to kind of go, what the hell is happening here, right? The clue really is the 9 here. All right. And this is something that you need to understand, because once you get this clue, this whole thing just becomes a lot more easier. So the first thing I want to show you guys, write is 9 is equal to 3 squared, right? So then we can rewrite 9 to the power of n minus 2 as 3 to the power of 2 to the power of n minus 2. So 9 to the power of n minus 2 could be said as 3 to the power of 2n to n minus 4. All right, that's the first step that you want to actually have. So then what I'm going to do is I'm going to rewrite this as 3 2n minus 1 plus 3 to the power of 2n plus 1 divided by 3 to the power of 2n minus 3 to the power of 2n minus 4. Now the next thing to understand is that when we actually have 3 to the power of 2n, see how 3 to the power of 2n is common everywhere? So what we could do is we could actually rewrite 3 to the power of 2n minus 1 as 3 to the power of 2n times 3 to the power of negative 1. Because remember, if the bases are the same, then you could actually add the powers. And I know some of you might be thinking, oh, but why don't you just put the 3 to the power of, shouldn't 3 to the power of 2n minus 1 equal 3 to the power of 2n divided by 3 to the power of 1? Yes, that's correct as well. But for this particular case, it would be a lot easier to go with this format. And let me show you why. So what I'm going to do is I'm going to take out the 2n. So I'm going to have 3 to the power of 2n multiplied by 3 to the power of negative 1 plus 3 to the power of 2n times 3 to the power of 1. And now that's equal to 3 to the power of 2n in the denominator minus 3 to the power of 2n multiplied by 3 to the power of 4. Negative 4, sorry. So once we have that, what you should see right now is that you actually have a common factor everywhere of 3 to the power of 2n. So we're going to take that out. And when we take it out, inside we're going to get 3 to the power of negative 1 plus 3 to the power of positive 1. And that's divided by 3 to the power of 2n divided by 1 minus 3 to the power of negative 4. So when we do this, we actually cancel out both of our 3 to the power of 2n's. And the last part, we just need to put that in the calculator to actually solve it. So what we have is, let me see if this is going to work. So we have 3 to the power of negative 1 plus 3 divided by 1 minus 3 to the power of negative 4. Now we're going to get that, and we can actually rewrite that as 27 over 8. So what we're looking at is the answer that's actually fully simplified to be 27 over 8. So grades wise, crazy question. Final answer gets you an excellence grade. Finds common factor of numerator and denominator gets you a merit. So I guess somewhere here gets you a merit. Correct answer only. So if you just put the correct answer only, you get achieved. So if you had actually, by some miracle, just got to the 27 over 8, then you only get achieved. Cool, that's question 3C. All right, let's go to question 3D. Possibly the worst time to be talking about viruses, but you know what? End of 2019, this wasn't really the case. But anyway, let's have a go through this question. So what we have is, with always these types of questions, you know, just highlight all the important parts that's important to you. Important parts is important to you. You get what I'm trying to say. So we've got something that's increasing, all right? And it's increasing by 5.3%. So that's where this 1.053 comes from. Luckily, they've actually given you guys this equation, so that's actually quite nice. Then the next thing they're saying is that if NO is the number of people initially diagnosed, so this is like your starting population. And then they're saying after T weeks, and blah, 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 N can be, yep, so they're giving you the formula. Now the question they're asking is how long will it take for the number of people diagnosed with this virus to be 3 times the original number diagnosed? All right. So in this case, we actually don't know how many people actually started with the disease originally. But what we do know is it's defined by N0, right? So N0 is at the start, the number of people at the start. And we want to know when will it be 3 times the number initially diagnosed. That means we want to know for 3 and O, T is equal to what? All right. So we know that NO, that's at the start. We know that T is equal to 0. So all we're doing is we're just literally writing this down. So 3NO equals NO multiplied by 1.053 to the power of T. That's all. Because now what happens is you bring NO to the left-hand side, and then that's equal to 1.053 to the power of T. So our NOs actually get cancelled out, and we're left with just 3 equals 1.053T. So at this point, we can actually figure out what t is, because t is equal to log 3 divided by log 1.053. Now, if you don't know how I just got to that, please do check out the level 2 algebra skills videos on solving exponential equations using logs. And yeah, there is some really good explanations there to actually kind of solve this. So we're going to go into our calculator and we're going to put in log 3 divided by log of 1.053. And what we have is 21.27. I don't know if that's weeks, months. Let's have a look. So we're going to put 21.27. And what are we looking at? T is weeks right there. So we're going to write down as 21.27 weeks. So grades wise, we're looking at a merit for this final answer. For achieve, taking log of both sides and t as a factor. Wow. Okay, I guess I kind of just skipped a step, but the achieved is doing this, where you go log 3 is equal to log 1.053, t as a factor. Yeah, I guess you can kind of say something like this would get you an achieved. So yeah, that's D1 right there, folks. Let's actually head down to D2 and see what that looks like. So similar question, similar type of question, but what they have is what we have. We've got something that's increasing exponentially at a rate constant r. We don't know what the rate is. We know what the initial people that got diagnosed. So initially it was 2,500. So that means when t is equal to 0, we can say that n naught is equal to 2,500. I'm just using the formula from before. And then they want to know, they're saying that after 10 weeks, the number of people has 4,250. So we can say that t is equal to 10, n is equal to 4250, and you're actually asked to find what r is. So that's what the ratio of increase is, right? So we're going to write this equation down. So n is equal to n naught, and then we've got r of t. All right, now we don't know what that r right now is, but we're just going to put it, but remember it's not r, it's actually 1 plus r over 100. So we're going to write that as 1 plus r over 100 to the power of t. Now you might be going, whoa, where did that 1 plus r over 100 come from? If you remember the previous question was 5.3% increase, right? And remember this, we did this, when you're increasing by a percentage, you actually go 1 plus 5.3 divided by 100, and then you end up with 1.053. So that's exactly what we're doing in this case to try and figure out what r is. So let's actually start putting all these numbers. Now n is equal to 4,250, n naught is equal to 2,500, and we've got 1 plus r over 100 to the power of 10. So rearranging this, we're going to get 4,250 divided by 2,500 is equal to 1 plus r over 100 to the power of 10. Need my calculator. So what I've got is 4250 divided by 2500. That gives me 1.7. So what I have is 1.7 is equal to 1 plus r over 100 to the power of 10. Now remember, if I want to get rid of the power of 10, I just need to multiply both sides by 1 over 10. The powers by 1 over 10. Because if I multiply the power by 1 over 10 here, then it becomes 1. And I'm also, remember that 1.7 has a 1, and I'm going to multiply it by 1 over 10. The power, anyway. So I'm going to get 1.7 to the power of 1 over 10 is equal to 1 plus r over 100. So at this point, I just say 1 over r, 1 plus r over 100 is equal to 1.7 to the power of 1 over 10. And as you can see, I'm getting 1.0544. So I'm going to put that down as 1.0545. So at this point, I just need to rearrange to figure out what r is. So I'm going to get 1 r over 100 equals 1.0545, and I've got to do -1, and then r over 100 is equal to 0.0545, and then r is equal to 100 times 0.0545. So r is equal to 5.45%. So we can say increasing at 5.45%. Okay, so we've actually kind of figured things out here. So for grades wise, percentage rate of change found is worth an excellence. Finds 1 plus r over 100, so that's going to be a merit there. Sets up correct equation is an achieved. So that's what we're looking at there, folks. Okay, so let's go to the last question. Alright guys, so with this question here, what we actually have to figure out first is we got to actually figure out what k is first. Once we figure out what k is, then we can actually figure out what the horizontal distance here is. So the final part of the question, which is right here, find the horizontal distance of the anemometer from the left tower. So you can see it in the diagram. That's what you're trying to figure out. All right, that distance there. So you're trying to figure out when h is equal to 100. So h is equal to 100. What is x equal to? So to do that, we need to figure out what k is first. So what I'm going to do is I am going to kind of not, I'm going to see if I can try and redraw this roughly. No, we don't need to redraw it. Here we do. Yeah, well, okay, let's have a look. One bit of the information that's really important is right here. It says at midpoint between the two towers, the suspension cable are 67 meters above the water level. So what we can then say is that distance there from there to there is 67 meters. So we've been given the equation, right? The equation is this right now. Y is equal to k x minus 640 squared plus 67. Sorry, let me just show that again. Just need a bit more space here. So y is equal to k x minus 240 squared, sorry, 640 plus 67. Now we need one point to actually work with, all right? And we can't use the 640, 67, but instead we could use this point right here, which happens to be 1,280 and 227. So I'm going to use that point, 1,280 and 227, and I'm going to substitute it in to try and figure out what the value of k is. So I'm going to get 1280 minus 640 squared plus 67. So subtracting it, I've got 227 minus 67 equals k times 640 squared. And so k then is equal to 160 divided by 640 squared. So k is going to equal, if I can get my calculator, 160. What do we have? Oh, lovely. We got one of these numbers here. So that is, how many decimals is that? That's going to be 3 zeros in there. So it's going to be 0.000390625. So that's what my k value is. So at this point, I need to substitute. I'm going back to point A. So point A is like this. I don't know what x is, but I know that that's equal to 100. And so right now, I need to substitute this back into the quadratic equation to try and figure out at what value for x is the height at 100. So I have y is equal to k, which happens to be this lovely long number, times x minus 640 squared plus 67. So now I'll put this as 100 equals to 0.003900625, x minus 640 squared plus 67. So what you could do is you could expand this equation and try and kind of work it out. That's one way to do it. But if you're confident with your quadratic equations, then what you could do is you could, like, let me just rephrase that. You could actually expand this quadratic and put it into that ax squared plus bx plus c form, put it equal to 0, and then get the two answers. That's one way of doing it. The other way of doing this is actually by rearranging and taking square roots. So what I'm going to do is I'm going to do 100 take away 67, and that's equal to 0.000390,625 x minus 640 squared. So 100 take away 67 is 33. 33 equals, I really hate this number in terms of how big it is, but guess what? This is what we're dealing with. So then we're going to get 33 divided by 0.00390625 equals x minus 640 squared. So let's go back to my calculator. I'm just going to go 33 divided by the answer. That gives me 84480 equals to x minus 640 squared. And this is what you could do. You could say that x minus 640 is equal to square root of 84480. And I really hope this works, because otherwise I have to go back and redo this entire video again. So I've got 290.65. So this is going to be plus or minus 290.65 equals x minus 640. So if we look at it, we can rearrange this as x is equal to 640 plus or minus 290.65. So there's going to be two answers. Our first answer is obviously 640 plus 290.65, which is going to be 930.65. Or our second answer is going to be, I think I do need the calculator for this. So 640 minus 290.65. So we get 395.35. So we actually have two answers for this, and the reason that there's two answers for this is because if you look at it, there's actually 2 points where the height is at 100 meters. So the first one being the 395 one is right there. So that's the 390, sorry, not 395. Did I make a mistake? Oh, 349.35. So that's got to be 349.35. So that's this point right here. And then the second point is 930.65. And so because we're looking for it from the left tower, so we can actually say distance from left tower equals to 349.35 meters. Yeah, another long question here, and it's partly because of I just have to write that k value so many times again. You know, I don't know why you have to give such a horrible number. Could have actually given me a smaller k number to actually work with, but guess what? That's what actually happened in this question. So, looking at grades, k value, finding the k value gets a merit, or two consistent answers from the wrong k value, and then your final answer ends up getting an excellence. Alright guys, there was a much longer paper than I would have liked to. I mean, if you think about it, it's taken, this paper is supposed to be done in 1 hour. It's taken me 1 hour and 14 minutes to explain. So yeah, I think it was a little bit of a long paper. But anyway, as for you guys, just please make sure that you guys answer as many parts of the question, because you never know what you're going to get, which question might get converted to an excellence in these types of situations. So make sure you attempt all the questions and never leave a question actually empty. And of course, if you guys have any questions about any of these things, just write in the comments below and I will try my best to answer them. And as always, guys, don't forget to share this video, like this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out, and some skills revision stuff popping up as well. Cool, that's it from me. Thank you for watching and your ongoing support.